Now let us see some of the master data of quality management in details. Let's start with master inspection characteristics. What is a master inspection characteristic? An inspection characteristic that is created as a master record is called a master inspection characteristic. We call it MIC in short. MICs are used in inspection plan for evaluation of quality test on the material. So if you want to test certain quality parameters of a material, then that tests are represented as master inspection characteristics. Master inspection characteristic is created as an individual master record and then used inside or assigned to quality operation in an inspection plan. These inspection plan, which are in itself are a master data, are copied into inspection lots when they are created. For example, at the time of good receipt of a raw material from vendor, when it is received in our premises, we do enter the material and its quantity in good receipt material document. And while saving that material document, a new inspection lot is generated, thereby meaning that the incoming material is required for testing before it can be used further in production process. Now, in an organization, it may happen that not all master data are or not all materials are subjected to quality testing. We can manipulate the master data like material master in a way that no inspection lots are generated for those materials on receipt. The transaction codes of master inspection characteristics in SAP, which are used in maintaining MICs, are QS21, QS23, QS24. QS21 is used when you create an MIC newly, whereas QS23 is used when you want to change a already created master inspection characteristic. QS24 is for display mode for viewing existing master inspection characteristic. Now this slide gives you the SAP screen of QS23 transaction, which you see on your right. Let us see what all fields are available in this transaction. First, master inspection characteristic can be quantitative or qualitative in nature, meaning if the quality parameter can be a measure or can be measured as a quantifiable value, then we would define that MIC as a quantitative characteristic. Whereas if an MIC can't be quantified with a value, those inspection characteristics are created as qualitative characteristics. A very simple example that comes to my mind in case of quantitative characteristic is a pH value. pH value of a liquid is measured in terms of whether it is acidic, alkaline or neutral. There is a range associated with it from 0 to 14. If it lies between 0 and 7, it is termed as acidic. If the value is 7, then it is neutral, whereas anything which is greater than 7 is alkaline or basic. These all ranges can be modeled in an MIC, and it is a perfect example of quantitative MIC. Whereas a qualitative MIC can be color of a corn, for example, golden color, pale yellow or yellow. There is no value in terms of a number associated with it. Hence, it is termed as qualitative characteristic. Inspection characteristics can be created as a complete copy model or an incomplete copy model or a reference model. As you know, MICs are master data and used in an inspection plan. Now, MIC in itself can be created as a copy model or a complete copy model, meaning when an MIC is inserted into an operation, there is no data maintenance required in an inspection plan. You have all the data available in MIC, which you maintained in QS21 transaction, to make it functional in an inspection plan. All the data from MIC is copied into an inspection plan when you create that inspection plan and insert that MIC into it. Whereas in an incomplete copy model, it is more like a complete copy model. The only difference is that the incomplete copy model, when inserted into an inspection plan, requires some data maintenance within the inspection plan. For example, specification ranges may be missing in incomplete copy model. Incomplete copy model might be useful in cases where you have same MIC but is using multiple inspection plans, or in business parlance, if the same test is performed across material categories, then we might have different specification ranges which we need to take into consideration. Hence, it is advisable to use or to create that MIC with an incomplete copy model, wherein you can maintain different specification ranges in the inspection plan itself, which will be different across different inspection plan for that same material or material categories, right? Now, a reference copy model in an MIC is one in which you have all the data available to make that MIC functional in an inspection plan. Here, it is very much similar to the complete copy model. But the difference is, once MIC is copied into inspection plan, and if there is a change required in any of the fields inside that MIC within an inspection plan, then you need to change it at the MIC level, meaning you have to go to the transaction of MIC, which is QS23. You need to edit that specification ranges, and then the system would automatically copy it into that inspection plan. So what does it mean? In a reference copy model, you cannot make changes to the MIC which has been copied in the inspection plan. You have to do that in the MIC transaction itself. A case for this would be a quality parameter that does not undergo any change and has a fixed value. In those cases, it is advisable to use a reference copy model of an MIC, because irrespective of where the MIC may be used, that is multiple inspection plan, the specification value required for the characteristic remains constant. Hence, to ease master data maintenance, these MICs can be created as reference, and changes are done in MIC itself, and changes will be reflected in inspection plan to where it is assigned. Difference between a complete copy model and a reference model is that if a change is required in MIC specification value in complete copy model, we need to maintain that MIC value in inspection plan separately. Whereas in reference copy model of a MIC, one needs to change that in the master inspection characteristic transaction, which is the QS23 transaction. In the same screen on your right, you can see that there are other fields which are available, like plant, MIC name, key date. These three fields are used to create an MIC. MIC are referenced with these three primary keys, or they are basically distinguished with these three primary keys. Or in other words, you give the inputs before you start creating them. Key date represents from when one wants an MIC to be active and functional. You can also do versioning of the MIC if you want to modify the existing MIC with some additional information or data. Class characteristic is another interesting field. Generally, you use or specify class characteristic when you want the MIC actual value which you have measured during your result recording to flow into the batch characteristic. Let's again take the example of pH value, wherein whatever measured value during result recording, right, or the quality testing you have got, that value must flow into a batch characteristic value. In other words, for example, you have just received a finished product from your manufacturing operations, and based upon that pH value obtained, the finished product with a certain value range may go to a specific customer who have requested that value of that finished product. In this case, if you can provide class characteristic in MIC, the value flows into that batch characteristic value, which then be taken into consideration when you are fulfilling customer orders. That is generally done through batch determination during sales order processing. There are other fields like short text, search field, and inspection description. These all can be filled and can be used and help in maintaining inspection description. One can smartly make use of these available fields in MIC, which can be very useful in searching a specific MIC. You may not have known the MIC number, right? There may be hundreds of MIC. You can't remember each and every number, right? Which is basically this number is a system generated. So it is better to have those search fields, short text and inspection description filled with certain logical description so that you can call it once you need it. It helps in improving the overall efficiency of master data maintenance. Also, one specific use can also come when you are writing a custom logic and creating a Z enhancement to act for only a set of MIC. These can then be used as alternative and built into logic while creating that enhancement. Characteristics need to be released in order to be used in an inspection plan. In order to be functional, you must select the status released and then you are good to go. Okay, now this next slide talks about some more details of an MIC, which are to be maintained before an MIC can be used or made functional. These are called control indicators. Remember, based on whether that MIC was created as quantitative or qualitative, there would be slight changes in the field you may see in these pop-up screens when you hit the control indicators button at the top left-hand corner. For quantitative characteristics, you define lower specification limit and upper specification limit. It is not mandatory that all the characteristics which are quantitative in nature need to have upper and lower limit maintained. You may only check the boxes for which you need it. Same is the case for target value field. If your characteristics does not fit into ranges but has a specific value attached to it, then you may assign a target value. These all values you may be able to maintain when you click on quantitative data button, which is present in the initial screen of MIC. More so, you can find it in the middle section. It will be seen as a button, quant data. Now, apart from specification limits, we also have checkboxes for sampling procedure in this pop-up screen. If you have sampling procedure assigned, or meaning you have defined how many samples are needed and how they are evaluated by the system. More details of this sampling procedure we will obviously go through in our next lesson. Another field, SPC characteristic. Check that box if your characteristic falls under the ambit of statistical process control characteristic. And you have all sorts of charts, means, variances to define those. You set the indicator for an additive sample if the inspection of an inspection characteristic is destructive. You may set the indicator for destructive inspection in case you are going to destroy the sample after testing. Another subscreen is result confirmation screen. Here in this, you may define whether you are going to do a summarized result recording or single value recording or no characteristic recording or classed recording. You may choose any one option from the four. You may also choose a checkbox for defect recording. You may also mention whether the MIC is mandatory to be inspected or is it optional or has to be inspected based on certain conditions like after acceptance or after every rejection. You can also choose the inspection scope, that is, whether the number of inspected units at result recording can be smaller or greater than the pre-calculated number of units to be inspected. Here you define scope as not fixed, fixed, smaller scope or larger scope. You define if and when additional text is to be entered when you record results for documentation purposes. You define that the inspection is to take place over a longer period of time. The usage decision can already have been made and the vendor can have them evaluated. You define whether the fraction of non-conforming units for this characteristic is taken into account when the scrap share for the inspection lot is calculated. This only occurs if specific quality scores are used when the usage decision is made. You define whether change documents are to be written for result recording based on characteristics. You define whether you can assign test equipment to the master inspection characteristic in the task list. You define whether and under which condition the master inspection characteristic is printed on the inspection instruction. You define whether you reference codes from a selected set in result recording or whether you evaluate manually with accepted or rejected. If you set this indicator, if it affects the assignment of code groups and codes. You define whether defects are to be recorded if the characteristic is rejected. Apart from these fields, we can also provide some additional information like authorization group, inspector, quality qualification, and weighing of characteristic. And plus there are some important fields like info fields which are available. Apart from these fields, there are some fields like short text, search field, and inspection characteristic, which can also be very uniquely used. And the short text and search field can also be used in certificate generation, as well as you can also include those in custom development based on logic. Moving on, we come to our second master data in quality planning, which we are discussing here. It is inspection method. An inspection method is used to define procedure and execution method for inspection. An inspection method can be assigned to a master inspection characteristic or assigned directly to characteristic in an inspection plan. An inspection method is created with transaction QS31 and changed with QS33 and displayed with QS34 transaction. Okay, now in this slide we are in QS34 transaction. QS34 transaction is the display inspection method transaction, and you see screenshots on your left and on your right, basically giving you details about the inspection method. As you can see on the screenshot on your left, for QS34, as you enter or when you execute QS34, you land up into this execution screen where you need to provide the plant and inspection method number. This inspection method number must already be there in the system, and you need to provide it because you have already created that through QS31 transaction, which is the create transaction of inspection method. So you provide those plant and inspection method and hit enter. You would be able to navigate to the next screen, which is the display inspection method version general data screen. As you can see on the screenshot on your right, details of inspection method display screens opens up. On the top, it has information related to inspection method, plant and version. In the general information subscreen, there is information related to status, language, short text and search field. You also have fields like authorization group, which can authorize certain individuals to view or change the inspection method. You can also provide inspector qualification value in inspection method, where you can define which qualifications an inspector must have to carry out an inspection. Inspector qualification can also be maintained in MIC. If inspector qualification is maintained both in MIC and inspection method, qualification in the inspection method takes precedence over that of MIC. There are a few more info fields which one can make use of when you are developing some logic around inspection method. These fields come in handy at those junctures where businesses would maintain the info field value. These are open text values which derives further logic or processing in the program. In the next slide, we will see a screen recording of creating an inspection method.